Welcome to our program, Astronomy for Everyone. On our two previous shows, we talked about buying and using telescopes. Now, assuming that you have a telescope, and especially one that has a motor drive that will track the objects in the sky, today we're going to talk about astro imaging. That is, the art of taking photographs of the objects that you look at in the night sky. With me here in studio is John Kirchhoff, a member of the Ford Amateur Astronomy Club. John, welcome to the program.
Hi, Don. Thanks.
Now, I see over here we have a telescope with an imaging setup. Can you briefly tell our viewers about that setup?
Absolutely. Let me walk over to the telescope here and kind of explain the basics.
All right.
You did mention a motorized drive. That's important with the telescope so that you can actually track your targets, okay, for doing astro imaging. On the back end of this telescope, we have an imaging camera. And the thing that's interesting about the type of imaging that I do, we're doing webcam imaging rather than using a 35mm camera. We're actually using a web camera to take pictures of the moon and the planets.
Interesting.
You can see it really doesn't look a lot like a normal camera at all.
No.
In fact, the chip is rather small on it. And the beauty of taking a webcam and adapting it to telescope use is that we can take a digital movie of the object. Many objects, when we're looking at them at high magnifications, we run into problems with seeing conditions. The image will go from being sharp to being blurry to being sharp again. A web camera will let us almost look through those seeing conditions and end up with a very, very sharp final image of the object that we're photographing.
Well, so anyone could really grab a webcam that they may be using for the internet, put it on a telescope and use it in that manner?
In most cases, yes. Many webcams could be adapted to a telescope. In addition to this particular webcam, I have a couple on the table over there. We have a little webcam by a company called Philips, and you can see this is just a normal little webcam, okay? And we can buy an adapter for this and actually have that fit where the eyepiece would go on the telescope, and then we'd be using it for photography. Again, the beauty of the webcam is that we can take multiple images very, very quickly and many images, save sharp images, and throw away the blurry images and end up with a resultant image that is much, much better than what we could get with a normal 35mm camera.
Well, I know you've brought a number of images with you. Why don't we take some time and show our viewers just what's possible by using a webcam?
Sure, absolutely, that'd be great.
Now, I understand that you can take really good images with a webcam of both lunar and planetary objects.
Absolutely, that's what the webcam is really designed for. Webcams came into use about 10 years ago. Prior to that, people took pictures with just a regular 35mm camera or perhaps like a CCD camera. And quite honestly, 20 or 30 years ago, the images that you would see that were taken by professional observatories, really you could see better visually with a small telescope rather than rather than the picture. The visual look was much better than the picture. But webcams have really changed the dynamic of the whole situation.
All right, well, why don't we go to some of the images that you've brought and we can show our viewers some of your work.
Okay, very good. This is a picture of an area on the moon. The crater at the bottom is the crater Copernicus. There is a ghost crater in the center of it called Stadius, and then a crater called Eratosthenes up at the top. If we were looking through a normal telescope, this is the view that you would see at 200 to 300 power magnification would be my guess.
Very interesting image.
Another crater, this is the crater Gassendi, and you can see rather than being a deeply dished out crater, this one has a rather flat basin to it. It's an older crater. There's been lots of lava and lunar regolith that have kind of filled that basin of the crater. You can only see the peak just barely sticking out in the center of it. When I say older crater, we're looking at a crater that's probably on the order of 1 billion years old or so.
Interesting.
Here's a couple other craters. We have Eratosthenes Hercules and Atlas, followed by Poseidonus on the right-hand side. There's a crater Kepler. If you take a look at Kepler, one thing that's really interesting about it, you can see those white areas that are illuminating off or radiating out from the crater itself.
Kind of look like rays spreading out from the center.
Precisely right. And that's actually a much fresher crater. That one's only a few 100 million years old rather than 1 billion. So it's had a chance to actually still be fairly undisturbed.
Interesting.
One of the brightest spots on the moon, in fact, the brightest spot on the moon, that is the crater Aristarchus in the center of this picture. It's been noted people have thought of seeing transient lunar phenomena from this crater, different lights and perhaps outgassing. I think by and large scientists think that that's probably a good vivid imagination nowadays.
Like the canals on Mars.
Exactly. Crater that I was actually, a series of craters that we were looking at last night, Theophiles at the bottom on the right. You can tell that that's actually the newest of the 3 craters. You have a crater in the middle called Katrina, and then one on the left that you can just barely see called Cyrillus. And you can actually see how one crater is fresher than the other, and then the other yet. So there's a lunar timeline there in that particular image. This is actually a basin on the moon called Chicard, one of the largest craters. To give you an idea of scale, we're looking at an area that's probably 120 to 130 miles across. This particular object has a zebra stripe running right down the center. 2 other craters, and we're looking at a fresh, very recently produced crater on the bottom and virtually about the same age up on the top.
Oh, very striking image.
Yeah.
As is this one.
Yeah. There we're going back to Aristarchus, and what you can see with Aristarchus, we're looking at the lunar limb, so that gives you an idea of the area that we're actually covering with that webcam. That crater's about 30 miles across, to give you an idea.
And that's the edge of the moon that we're seeing, and
On the
black
right-hand
to the right
side.
is the black of space.
Exactly right, yep. An unusual object, this is the crater Schiller, and you can see here there was a lunar a meteor strike that hit at a very oblique angle, and it caused the crater to have a very, very elongated shape.
Sort of like a cigar shape almost.
Exactly right. And we also have, I think, one of my favorite spots on the moon. This is the Bay of Rainbows. It's called Sinus Iridum, and again, a huge meteor impact once upon a time. The lava flow has gone ahead and filled that virtually up all the way. You can't see the rim of the crater up at the top. It's been totally engulfed by the lava.
So that smooth area is the lava that filled in the crater.
Exactly, and the ancients actually used to think that those were seas, and they have names like bays and oceans and seas.
Ah, very interesting.
Okay, and one of the, I think this is our last lunar image, the crater Clavius, and that's another very large crater in the southern highlands of the moon.
So see if we have a few other images to show. Did you bring any planetary ones with you, John?
There are a few planetary ones up. Planetary images are much harder to go ahead and shoot, but I've given it my best shot.
All right, well, let's see if we can bring those up and show them to our audience.
Okay, this is the bright planet that we're seeing in the western sky right now, Venus. And you can see it actually exhibits a phase like the moon.
Interesting.
Yep. Mars was very bright this winter, and it was a very bright orange-red colored star, and you can see the northern pole cap very brightly up at the top there.
You can also see various surface features, the light and then the dark.
That dark area is called Sirius Major. That's one of the most notable features on the Martian surface. Another photo of Mars taken a few days later, different hemisphere. If you look at the blue on either area, that's a little bit caused by the atmosphere of Mars. Mars has a very thin atmosphere, but it's there. The mighty crater, or the mighty planet Jupiter, that's actually coming up in the morning sky right now, shortly before dawn, and a couple of its moons.
Oh, I see you have the 2 points just along the right edge there, and the one that is viewed with the backdrop of space.
And to give you an idea, those moons are about the same size as our moon, but shot from a little bit further away.
Great.
And finally, a lot of people's favorite, the planet Saturn. And right now, Saturn's rings are virtually on edge, so we don't see much of opening of Saturn's rings, but that'll be opening up over the next couple, 3 years.
Everybody always likes to take a look at Saturn. It's one of my favorite objects to view as well.
Absolutely, absolutely.
Well, John, we really appreciate you bringing your images along for our viewers to see. We hope that you've enjoyed taking a look at these planets and the moon of our solar system and the moon of Earth. And after this short public service announcement, we'll be back with another one of our club members who will have images of the deep sky. Stay tuned. We'll be right back.
There is really only one boy. One girl. One tree. One forest. One deep, dancing ocean. One mountain calling. One handful of sand through our fingers. One endless sky overhead. And one simple way to care for it all. Please visit earthshare.org and learn how the world's leading environmental groups are working together under one name, EarthShare. One environment, one simple way to care for it.
Welcome back to our program. For this next part, here with me in the studio is Gordon Hansen, also a member of the Ford Amateur Astronomy Club and chairman of the club's Astro Imaging Special Interest Group. Gordon, welcome to the program.
Thank you, Don. It's a real pleasure to be here.
Can you tell our viewers a little bit about what the Astro Imaging Special Interest Group does within our club?
I think that the title kind of sums it up pretty good. You know, we're a group of about a dozen or so members of the club that have an interest in doing astrophotography. And so we get together once a month to share our images, share techniques, learn how to do things. So it's a way to educate ourselves and to bring ourselves along in this, what's really an art form. You know, unlike what professional astronomers may do in an observatory where they're trying to take measurements of stars and learn things, we're really out there trying to take pretty pictures. So it really becomes an art form rather than a scientific endeavor.
Now, we're going to show our viewers some of your images of deep sky objects like galaxies, nebula, that sort of thing. And the cameras that you use are a little bit different than the ones that John used. Can you tell our viewers about that?
Sure, exactly. You know, when John was talking earlier about the lunar and planetary, you got some relatively bright objects. Planets and the moon are bright, so you can take a lot of very short focus, short exposure length images. With deep sky, we're going after some very, very dim objects. Most of these objects, that are even very, very difficult to see through a telescope, so they're dim. So rather than take a whole lot of short exposure images, we're after a few very, very long exposures. And long exposures now can be 15 minutes, even 30 minutes in length. So we're at an entirely different place in the spectrum. What people tend to start with are typically ordinary consumer point-and-shoot cameras, 35 millimeters. I show a Canon camera here. That's one of the cameras of choice. And we're going to start with some of the images later, but even just starting with a telephoto lens is a way to get started with astrophotography. If you think about it, the telescope that John was showing before is really nothing but a big telephoto lens.
Exactly.
So the camera is attached in exactly the same way. But now instead of taking really short exposures, we're taking very, very long exposures.
And so obviously this lens comes off and you can
Yes.
attach the body of the camera right to the
Right,
telescope.
so this come off and we would attach the body of the camera right to the telescope, and the telescope then becomes a telephoto lens. This is a regular, like I said, a consumer 35 millimeter camera, and you can do some really good work with this type of camera. The other type of camera, when you start getting a little more specialized, becomes some dedicated astro imaging cameras.
So this you couldn't use to take pictures of the family pet.
Well, you could, but it'd be kind of difficult. You'd have to find a way to get a lens attached. I mean, this is designed to go directly onto the telescope. The really big difference between this type of telescope and this and the 35 millimeter type telescope is this one has got cooling built in. Because when we take really long exposures, when a heat signal builds up on the chip and can start causing noise images. So this camera, it can you can almost see the fan on the backside. This gets cooled down to about 40 degrees centigrade below whatever the ambient temperature is. And that allows us to get the noise threshold down.
Which makes for a clearer image.
Makes for a clearer image, exactly.
Right. Very interesting. Why don't we start to take a look at some of the images that you've been able to capture, with I assume both of these types of cameras.
Yep, let's go right into it. Now, you don't even need a telescope or even a mount. This is what we call star trails. This is taken by another one of our members of our club, Jim Frisbee, and essentially putting a standard camera on a tripod and just pointing it, in this case, up at the north celestial pole, and let the camera just sit there with the shutter open for a long period of time. My guess is that he probably took a 50 or 60 1 or 2 minute images, or even longer than that, to get about 3 or 4 hours worth of exposure. And you can see the stars rotating around the night sky. So you can see the brightest one in the center is Polaris, and we call that the North Star, but it's not exactly at the celestial pole. You can see the fact that it's spinning around.
Very interesting. Let's see what's next.
Okay, this is another one that we're taking with with just a normal telephoto type lens but this time on a mount that's tracking. This is the constellation Cygnus, which is a summer constellation. When we look up in the night sky with our naked eyes, we'll see the 4 bright stars that form what's sometimes called the Northern Cross. And that's about what you'll see. But you can see in this image, and this is what the beauty of astrophotography is that we start picking up a lot of the dim light that our eyes can't capture. And so in a long time exposure, the Milky Way is running directly through Cygnus.
And that's
so
what we see in the background of this photo?
Right, and what we're seeing in the background now is the Milky Way. That's why there's so many stars in here. But the red is coming from hydrogen gas that's being excited by stars in the vicinity, and it's causing it to glow red.
Interesting. Gordon, tell us about this next image.
Okay, we're going to jump now into some what we call deep sky imaging now. This is obviously taken out through the telescope, and we're going to start talking about some globular cluster first. The first one here is called M13, the Hercules cluster. It's about the biggest globular cluster we can see from our latitudes here on the planet. It's about the third of the size of the moon, if you looked at it through a naked eye. So these objects are not all that small, but they can tend to be dim. Hercules cluster on a dark site, you can actually see a smudge of light in the sky. So this one you can see. For what it's worth, it's about 25,000 light years away. So we're outside the solar system, that's for sure.
All right, let's see what's next.
Okay, this next one is the granddaddy of all the globular clusters. This one is called Omega Centauri. Unfortunately, we can't see this one from Michigan here. You've got to get further south. This was an image I took down in Florida. This is a huge cluster. It's probably about twice the size of the moon is. So it's,
Okay.
this is a big image, and when you look at this again, naked eye, there's a blurry patch in the sky, but it's massive. Interesting. It's classified as a globular cluster, but it may not be one in the true sense of the word. The professionals today think this is actually the remnants of a dwarf galaxy that's been assimilated by the Milky Way, and this is the core of that galaxy that's left.
Interesting.
There's some real strong evidence that there's a black hole in the center of this, so that's part of the evidence of why they think it's the remnants of a galaxy. It's about 16,000 light years away, so we're getting out there a little bit.
All right.
Okay, one of everybody's favorites is the Andromeda Galaxy. This is the sister galaxy to our home galaxy, the Milky Way. In the sky, if you get to a dark spot, you can see, especially the center of this can be seen naked eye. It's probably, again, about twice the size of the moon in apparent size in the sky. We're getting pretty far out now. This is about 2.5 million light years away.
All right.
It's one of the galaxies that actually is blue shifted. We hear people talk about redshift, that the galaxies are pulling apart. Andromeda is actually moving closer to us. And in about 2.5 billion years, our galaxy and the Andromeda are going to start to interact and collide with one another. So the night sky is going to be pretty interesting. I can't wait to be there.
Me neither. What do you have next here, Gordon?
Okay, we'll take another galaxy. This one is called NGC 7331. It's another pretty spiral. We've really pulled away from our home planet here. We're about 40 million light years away. And you can see some other galaxies starting to pop up in the background. Now, all of these images that we're showing now, especially these galaxies, we're probably talking at least 1.5 hours to 2.5 hours of exposure to pull these out. These start to become dim. This one you could not see with your naked eye. Next one is the Pinwheel Galaxy. This is a kind of a face-on spiral.
I can see why they would call it that.
And this again is pretty big. This is about the same size as the moon in diameter, but dim. This is a really tough one to see even with the telescope. You got to be in a dark sky. I think that's kind of the beauty of astrophotography and why you get interested into it, because you may be able to find some gray, faint fuzzies in the sky through an eyepiece, but to pull out this detail and the color is
That's fascinating.
the only way to do that is through long exposure astrophotography. This is a little bit different tack. This was taken through a special hydrogen alpha filter. And this is called the Horsehead Nebula and the Flame Nebula area.
I can see them there on the right and the left, respectively.
Right. They're actually two dark nebulas. With the Horsehead, as you can see, it is actually a dark cloud that's sitting in front of an area of glowing gas. So it's really done in silhouette. Another really pretty one is called the Cocoon Nebula. Again, as I said earlier, a lot of this is we're looking for the artistic and the pretty pictures type thing, and certainly this is as colorful as we can get here.
I can see the interaction between the red clouds of gas and the dark dust lanes. It makes for a very interesting image. Gordon, these have been some great images. I'm sure our viewers have enjoyed seeing them. If any of you have any questions about photography or astro imaging, you can send us an email to our email address that you'll see at the bottom of your screen. And also, don't forget to check out our website. We'll also have that address at the bottom of our screen. And right after a list of upcoming astronomy events in our area, we'll have our last segment, What's Up, with Steve Whitty. Stay tuned.
going to start with a little observing report from April. On the 11th, I was in my living room. I was looking out the window, and there was a bright thing there. It could only be Venus. My living room faces west. I thought, could I see Mercury? And I looked for just a few seconds, and there was Mercury, right where I expected it to be. It doesn't get easier than this. I was sitting on the couch. I didn't move my head. A lot of professional astronomers have never seen Mercury. It never gets high enough above the horizon, sticks close to the sun. So what's up for May 2010? Well, April ended with a full moon on the 28th, so May starts with an essentially full moon. On the 6th of May, we have third quarter, and the moon is a morning object. On the 14th, the moon is new and very hard to see. On the 20th, we have first quarter, so it's up all evening. And on the 27th, the moon is once again full. May has longer and longer days, and we're going to have longer days until late June. So May starts with sunrise at 5:30, but by the end of the month, sunrise is at 5. And sunset starts the month out at 7:30 p.m., and by the end of the month, it's 8, so we gain half an hour in both directions. Venus starts out by setting at 9:50 p.m., but by the end of the month, it sets at 9:40 p.m., and if you do the math, you get an extra 20 minutes to spot Venus if you can. Due largely to daylight savings time, Leo is once again essentially straight overhead at 9 p.m. All month. Now, Leo has Saturn sort of to the left and Mars to the right, and so you have the big constellation, big bright constellation, Leo in the middle. Mars on the right, if you look at Mars and you use that as a waypoint, and you use your hand to go just to the right of Mars, about a hand width, you can see an open cluster, and it's called the Beehive cluster. Now, it's naked eye in dark skies, but it's a binocular object in any skies, and you should be able to get both Mars and the Beehive cluster, M44, in just the edges of your binocular field of view this month. Now, on May 4th, we have a meteor shower that peaks. It's the Eta Aquarids. They start in April, and they end around May 12th. The meteor shower particles come from comet Halley, Halley's comet. So you should look to the east-southeast up until whenever the moon rises, and you should be able to see a few meteors from dark skies. So that's what's up in the night sky for May 2010. Let's go out and do some observing.